Hey guys, welcome back. Today we are going to be working on two questions that I took from my GMAT review book. I will leave a link to this book in the description, but you can go ahead and just follow along. I went ahead and typed out the questions. Sorry if there are any typos. I was kind of in a hurry. But anyways, these questions are also going to be seen on the SAT and also the GRE. And also probably in your algebra class. These are essentially just a type of rate word problem. So let's go ahead and jump on in. So this question says, the water from one outlet flowing at a constant rate can fill a swimming pool in 9 hours. The water from a second outlet flowing at a constant rate can fill the same pool in 5 hours. If both outlets are used at the same time, approximately what is the number of hours required to fill the pool? So the first thing I want to do is focus on the rate of the first outlet. So we know that the first outlet can fill one pool in 9 hours. So now let's take a look at the second one. So now the second one is also flowing at a constant rate, and that can fill the same pool. So again, we can say one pool in 5 hours. So now it says if both outlets are used at the same time, approximately what number of hours is required to fill the pool? So again, you want to take note that you're looking for hours. So since we know that both outlets are being used at the same time, we're going to go ahead and add these two quantities. So when we add these, we're going to need to get a common denominator, which is going to be 45. So I'm going to multiply this fraction by 5 over 5, and I'm going to multiply this fraction by 9 over 9. So over here, we're going to get 5 pools in 45 hours. Hours. And here we are going to get 9 pools in 45 hours. So now that we have a common denominator, we can go ahead and add the numerators. And this is going to give us 14 pools in 45 hours. So this is going to become our conversion factor, and this is what we're going to use to convert pools into hours. And you'll kind of see what I mean by that in our next step. But just remember that both of them working together could theoretically fill 14 pools in 45 hours. So now it wants to know, since it just says to fill the pool, you only need one pool, right? So you're going to start with one pool here, and I use this little bridge setup. You can also just this basically just means multiply, so you could also just put the multiplication symbol here, but it's one pool, and then we put our conversion factor here. So we have 14 pools in 45 hours. So now we can cross-cancel out our units that are pools, the common unit, and we are left in hours, which is where we want to be. This means that it's going to take 45 over 14 hours to fill one pool. So now looking at the answer choices, we notice that they are all decimals. So what I'm going to do is just kind of guesstimate what this is, so then I can choose my answer choice. So I know that 45 over 15 is equal to 3. So I know, since this number is slightly less than 15, I know it's going to be a little bit over 3. So that leaves me to believe that it's answer D. And I actually know that the answer is D, but if you weren't so sure, you can also just divide this. So just do 45 into 14. But it's always a good idea, since you are pressed for time on these exams, it is always a good idea to kind of get a general idea of where the answer is, and then that way you can kind of figure out what it's going to be, because 2.5 is pretty far off, and so is 4.5. So the answer here in this case is D. So let's do one more example to make sure that you guys have got that down. So this is number 126. I forgot to put the number here, but I'll write it right here. 126. Oops. Okay, this thing doesn't like me. There we go. Okay, so let me go ahead and read this question. So this one says, it would take one machine 4 hours to complete a large production order and another machine 3 hours to complete the same order. How many hours would it take both machines working simultaneously at their respective constant rates to complete the order? So this is a very similar question to the above question because you have two separate machines and they're working on a common task, in this case to complete a large production order. So we know that the first machine is going to be able to complete, I'm just going to say one order in 4 hours. The second machine is going to be able to complete one order in 3 hours. So again, it wants to know if the machines work together, how many hours would it take to complete the order? So let's go ahead and add these. Again, we're going to need to get a common denominator, which is going to be 12 hours. So over here, I'm going to multiply this by 3 over 3. Over here, I'm going to multiply this by 4 over 4. That's going to give me 3 orders in 12 hours plus 4 orders in 12 hours for a grand total of 7 orders in 12 hours. So again, this means that the machines working together could complete 7 orders in 12 hours. But now we only need how long it will take them working together to complete one order. So again, we're going to start with one order. We're going to make our bridge and we are going to fill in this conversion factor. And again, a conversion factor allows us to convert from the unit of orders to the units of hours, or the unit of hours. So we want to put our 7 orders here so that we can cancel them. And we want to put our 12 hours here. So again, we can cancel this unit and we are left in hours. So now this tells us that we can complete one order in 12 over 7 hours. So now let's go ahead and take a look at our answer choices, and we are going to see that it's an improper, this is an improper fraction, but they turned it into a mixed number. So 7 into 12, that's 1 and 5 over 7. So we see over here that our answer is C, 1 and 5/7. And if you didn't know how I got here, how I did that was I did 12 divided by 7. 7 goes into 12 one time. 1 times 7 is 7. Subtract, you get 5. And then this becomes your fraction. So this becomes the numerator and this here becomes the denominator. So basically I just divided, I just kind of skipped steps and did it in my head. So again, I hope that that was helpful. There will be a link to the book I took this question from in the description. And if you have any problem requests, I will also leave my email down there. So feel free to send me an email. And if you enjoyed this video, please like and subscribe to my page. All right, thanks so much and good luck on your studies.